Okay, let's talk about arc length. So you probably know that the circumference of a circle, meaning the length of this curve as we go around the circle once, is 2 pi times the radius. So if we wanted to know what the circumference is of this circle, we know that the radius is 1.5 centimeters. So in this case, it would be 2 pi times 1.5. And let's see what that equals. 2 pi times 1.5 equals about 9.4 centimeters. Okay, so even though this circle looks pretty small, if I were to measure around the entire thing, it would be about 9.4 centimeters to wrap around this circle. Okay. Now let's think about, what do we think is the length of this curved part of this half circle? So not this line, that's pretty easy to figure out. You can just measure it. But this curved part, if the radius of this circle is 0.75 inches, what would the length of this be? Well, we know that the circumference is 2 pi times the radius, which we'll put 0.75. So the circumference would be 2 pi times 3/4, or 4.7 inches about. But we don't have a circle, we have half a circle. So the length of this should be half the circumference, because it's half the circle. So if I wanted to figure out what the length of this should be, I could just take this number and divide it by 2 to get 2.36 inches. And if I wanted to actually measure it, that should be about right. 2 and less than half. I know you probably can't see that well, but right about here is where that half circle ends. Great. So hopefully you can tell what's coming. With the quarter circle, we're going to do the same thing. And then we're going to figure out what a quarter of the circumference is. So circumference is 2 pi times 2.6 centimeters. So 2 pi times 2.6 is 16.34 centimeters. So if I were to draw this whole circle out, the circumference of the entire circle would be 16 centimeters. But this is just a quarter of that. So we're going to take a quarter of this and divide it by 4 to get 4.08 centimeters of length for this arc, this part of a circle. So hopefully so far this kind of makes sense. It doesn't need too much explaining, hopefully, because kind of your gut instincts here will be pretty accurate. Again, if I measure this, it is about 4 centimeters. So let's now make the jump from a fraction of a circle to degrees. So this first arc that I have here, I have the angle is 60 degrees, and I know that the radius is 2 inches. So I'm still going to find the circumference first. 2 pi times 2, this little symbol means the same thing as inches. So 2 pi times 2 inches is 4 pi inches. And then let's think about what I would need to do to figure out this arc length of 60 degrees. Now, maybe you can see that 60 degrees is 1/6 of a circle. So we can just find 1/6 of this number to find the length of this arc. That would be the same thing as we did up here. It's 1/6 of a circle, so I'm going to take 1/6 of this number, and that's going to be my answer. But it would also be nice to be able to use angles like 22 degrees. And 22 degrees is not some simple, easy fraction of the circle. So if you want, you can think about this 1/6 as being the same as 60 degrees out of the 360 degrees. That number is the same as 1/6. If I type 60 divided by 360, math, enter, enter, that's the same as 1/6. But I can put any number of degrees out of 360 and use that to figure out the arc length from the circumference. So I'm going to take this 2 pi r, and then I'm going to multiply this angle over 360. So this is what I would do in general. And in specifics, I'm going to do 2 pi times 2 inches multiplied by 60 degrees out of 360 degrees. So hopefully you can see where this approach is coming from. Instead of just multiplying by a fraction or dividing by something easy after I'm done, I'm multiplying by a fraction, and that fraction is just the amount of degrees out of the whole circle. This would totally work for 180 degrees here and 90 degrees here, instead of just cutting it in half or cutting it in fourths. Okay, so let's see what we get. I could leave this in terms of pi if I wanted to, but I'll just do 2 pi times 2 times 60 over 360, and I get about 2.09 inches. And if I want to measure this, trying to make the tape follow the circle as best I can, it is a little bit over 2 inches, which should make sense. There we go. So now let's see this approach for something like this where we don't have an obvious easy fraction. I can do 2 pi r times the angle out of 360. So I have 2 pi, the radius is 6 centimeters, and now my angle is 22 degrees out of 360 degrees. So I'm basically still finding the circumference and then multiplying it by what fraction of the circle is included here. So we have 2 pi times 6 times 22 over 360, and we get 2.30 centimeters. And this should actually match what I see. Yeah. There we go. Okay. So now we know how to find the arc length based on the radius and the angle in degrees. But a lot of times, since we're doing trig now, we will have an angle in radians. So let's think about how we could adjust this approach to relate to an angle in degrees instead. So we have the circumference is 2 pi times the radius, and then we have the angle, but instead of putting it out of 360 degrees, an entire circle measured in radians is 2 pi radians. So why don't I put that instead of the 360? Okay, but looking at this formula, we can do a little bit of simplifying here. Because I have 2 pi, and then I'm dividing by 2 pi. So if I take 2 pi and I divide it by 2 pi, those things just cancel out. And I'm left with the arc length being equal to just the radius times the angle in radians, which seems almost too easy to be true, but it is true. If I have a circle with a radius of 1 inch, that means that the circumference is 2 pi r, which would just equal 2 pi. Now if I want to know, so that would be 6.28 inches. Now if I want to know how long is this curve, my angle is 2 pi over 3, meaning it's 1/3 of a circle. 120 degrees would be another way to write that. So my circumference is 2 pi. I need to find 1/3 of that, so I'll just divide it by 3. Oh look, that's the same as the angle here. The radius was 1, so then the length of this arc is the same as the measure of the angle in degrees, or in radians. And that's essentially what a radian is. It's saying how many times could I fit the radius along this circle. The radius is 1 inch. 2 pi over 3 has a decimal value of about 2.09, which means I could take this radius and I could mark off 1 inch along the circle, 2 inches along the circle, and I would have a little bit extra. In 1/3 of the circle, I can fit about 2 times the length of the radius. Okay. So let's look at this circle and let's actually mark off the radians as we go around. So the radius of the circle is 2 inches, which means that if I measure 2 inches of curve along the circle, that's equal to 1 radian worth of angle. Okay, so here are 2 inches of length that I measured along the circle. That means that this angle is 1 radian. The length of this curve is 2 inches, the same as the radius. Now I'm going to do the same thing. Here's two radians of the way around the circle. Here's one more length of the radius, which is 2 inches. Here's 3 radians around the circle. So the angle here is 3 radians. Pi radians is a little bit more than 3, it's 3.14. So halfway around the circle should be just a little bit past this, which it is. So right about here. Here would be pi, 3 is a little bit less than pi. Okay? Then we can keep going. What is 4 radians around the circle? Actually, put my tape around. Here's 4 radians. Here's 5 radians. Here's 6 radians. So each of these sections that I divided the circle into has a length along the curve of 2 inches, which is equal to the radius. And for me to get around the circle, it takes 6 of those sections plus a little bit extra. In total, to get around the circle, we know that it takes 2 pi radians, which is equal to about 6.28. So around the circle, each radian is the amount of angle. It's not this length. This length is the length of the radius. The radian is this amount of angle where the arc length is always going to be the same as the radius. If I were to draw a smaller circle inside of this one, this would still be true. So I could draw a circle that has a 1-inch radius. Now this curve in 1 radian of angle has 1 inch of length. I could draw a circle with a 1.5 inch radius. Now this curve here has 1.5 inches of length. 1 radian is it's a pretty good slice of pie, right? It's the amount of angle where the length along the edge is equal to the radius. That's what a radian is. If we go halfway around the circle, that's 3 radians and a little bit extra. We call that number of radians pi. It's 3 and a little bit extra. That's how many times we'd have to use the length of the radius to get halfway around the circle. And we call that number pi. Cool. So, the main lesson here, to figure out the arc length, if you know the angle in radians, it's just the radius times the angle in radians. If you know the angle in degrees, you could convert to radians, or you could use this slightly more complicated formula. All right, hope that you're having a great day. Feel free to ask me if you have any questions, and I will talk to you again soon.